Okay guys, as promised, we started chapter 1 today, lesson 1 specifically. So hopefully I showed you in the morning how to set this up with your notebook, how you draw a line to leave a third of your notebook empty on the left. You take notes on the right and you put questions on the left to help you study for later. But just for the interest of saving time, I went ahead and did this ahead of time. So here's the deal. On the left hand side I put the name of the chapter, it's chapter 1. The name of the lesson is Factors and Multiples, which is on page 7 to 13. The essential question for this chapter is, how do you use equivalent rates in the real world? Again, we are going to use equivalent rates in the real world, believe it or not. Alright, for this lesson there are two specific lessons. Find the greatest common factor and find the least common multiple. Now I realize we did a little bit of this earlier, but that's okay. We can always do it again. For this lesson there are two vocabulary words. GCF, which is greatest common factor, LCM, which is least common multiple. Now, I want you to use the definitions that are on page 7 or in the glossary. Don't use internet definitions, not yet. Okay? Again, if you look on page 7, right there, look at the highlighted word. Those are the vocabulary words, and everything before it is a definition, right? You can also use the glossary, which was the blue section way in the back. If you remember, we did this. The blue section, right? All right. Now, just a reminder, you can use your notes during a quiz and or tests. So if you have the vocabulary there, the definitions, and I ask you to define a word, if you have it in front of you, then you can use it. It's fine. But chances are I'm going to ask you to write what you understand anyways. So write the book definition first, and then we'll go over a personal definition a little later, okay? All right. Now, normally I suggest you use the back, but since I have a composition book, it's a little harder to flip it over and all that, so I'd rather just do this. I just went ahead and... So if you want to save paper, by all means, use the back. I'm drawing a line down the middle. Alright, our first goal for lesson 1. I hope we can see it. Our first goal is to find GCF. Okay. Now, we're going to go over page 8, example number 1. Okay? As always, read the problem first if you're not sure what I'm talking about. Right here, page 8. Okay. Well, since I'm here anyways. There are 1 slice servings of 3 types of cake on a table. Each row has an equal number of servings and only 1 type of cake. What is the greatest number of servings in each row? Okay. Alright. What's going to get you guys are the word problems. And it's not because you don't know the math, but you got to figure out the English. All right. And if you notice, there's a little table we got to figure out. So we have 3 kinds of cake: marble, red velvet, chocolate. We have 10 servings, 15 servings, 20 servings, 20 slices, 15 slices, 10 slices. And from what I understand, you know what? I'm going to draw a table to show you what I understand. So we have a table with 3 kinds of cake. If you notice, I'm kind of copying the table. It's not a bad thing. You do what makes sense for you. And I'm going to draw a little... I know it's going to look weird, but that's okay. Here's my cake slice. Again, you don't have to be an artist. The goal here is to draw it so you understand what you're doing. Alright, we have 10 slices, 15 slices, 20 slices. Okay, so I guess the goal is you can have 1 row per cake. You want it to be all even and nice, pretty looking. Right, so the question is, how many slices are we going to have per row, right? And which will work fine. Obviously, we can't put 20 here, 15 there, and 10. It'll look all mishmashed. So you're trying to make it everything nice and even. All right. So to do this, we need to find the factors. Now, we talked about factors. Just a reminder. And you saw the video too. Factors are what you multiply. You get a product again. To get a product. Usually you get a bigger number if you, I don't know if you noticed that or not. So the numbers we're talking about are 10, 15, and then 20. I'm leaving a lot of space for myself to do work. Now if I make a mistake, I can always erase it. I should have used pencil, but I want you to see the numbers. All right, 10, what are the factors? Always start with 1. One group of 10. I can make 2 groups of 5. 3, I can't make groups of 3 out of this. No way, not evenly. Right? Groups of 4? No. 5, yes. Again, the video showed you, and I'm going to show you right now. 1 times 10, they go together. 2 times 5, they go together. Everything in the middle doesn't work. You can't make groups of 3, you can't make groups of 4. You can't make groups of 6, 7, 8, 9. Nope. All right, 15. 1 times 2. You can always start with 1. Always. You can't make groups of 2 out of 15. Right? You can make groups of 3 times 5. And I realize the way I'm writing it is not the way I'm saying it. But for right now, I just want to get the numbers down. Okay? 1 times 15, 3 times 5. And again, 1 times 15, 3 times 5. Okay? And then 20. 1 times 20. 2 times 10. 3 doesn't work. You can't make groups of 3 out of 20. What about 4? Yes. And like I said before, guys, if you need a times table chart, use it. There's no shame in using it, although you really have to start working on memorizing them. 1, 2, 1 times 20, 2 times 10, 4, and 5. All right. So what are the factors? 10, 15, 20. The factors of 10 are 1, 2, 5, 10. The factors of 15 are 1, 3, 5, 15. The factors of 20 are 1, 2, 4, 5, 10, and 20. Oof, that's a lot. Okay, this if you have yours or a highlighter, this might help. Okay. What are the common factors? What are the same factors? What factors do they share? Again, if you think I can make groups of 1, I can make groups of, and again, it has to be something that they all share, right? I can make groups of 2 for 10, but I can't make groups of 2 out of 15. I can do it for 20, but nope. It has to be something that all 3 share. Okay, so common factor 1 and 5. But then what's the biggest factor that they have in common? The greatest, which is the biggest, 5. Okay, again, I'll put this on the side. You know, and this is one of those things where I'm giving you the notes here, but if you notice things, you notice patterns, or something that makes you remember something else, please use this side for your notes, for your notes. Okay, now I'm just going to add something right here, just to remind myself. Greatest means biggest. Now, if you can't read my writing, you can always replay what I'm saying. Okay, the biggest number they have in common is 5. Okay, again, if you go back to the problem, what does that 5 mean? Which might be a question later on in a test. So the GCF is 5. So what? What does that mean? What does that mean? Okay, I have, remember the question way in the beginning was, how many slices of cake can I put per each row to make it equal? So I can have the same number of slices per row? That 5 means, again, let me put a little triangle here, and I'll put this, again, there's a connection there. That means I can put marble, velvet, and chocolate. I can put 5 slices. Again, I'm not an artist. Eesh, but that's okay. 5, 5, and 5. Okay? I can put 5 slices of cake per row. Right? I can't put 10 here. Well, I could put 10, but then I have 15 here. I'll have too many left over, right? And then I can put 10 here. I'll have 20. I'll have too many left over. It's just 5, 5, 5. That's the way it works out. All right. Now, again, I'm going to use another page. Please use the back if you feel comfortable. If you want to use the back of this, feel free to do that. All right. This is the Got It. Page 8, letter A. Okay. Let's read the problem. Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? All right. Well, again, it helps if you draw the problem first. Please draw it out. It doesn't take much. I know we're talking about a girl named Lana. Now, forgive me for doing this. Not all girls wear dresses now, but the way I grew up, I just got used to, again, drawing little girls with dresses. That's just the way I was taught. Things are different now. So I'm not trying to say anything by this, but we have a girl named Lana. All right. She's selling bracelets, right? Bracelets, again. Okay. A bracelet, right? Oh, that's kind of bad. All right, so she sold bracelets Friday. And by all means, use pencil, but I'm doing this so you can see it. Sunday, she sold bracelets. All right. On Friday, she earned $49. On Saturday, she earned $42. So she's selling these. And on Sunday, she earned $21. So the question is, how much did she charge for each bracelet? How much did she charge? It has to be the same price for all of it, for all of this to work. Okay. By the way, I know it looks like sand. Let me just finish the writing here. Sunday, not just Sunday. Sunday, and then sat for Saturday, Friday, obviously for Friday. All right, same thing. Greatest common factor. Okay. All right, I'm going to draw it a little differently. Well, maybe not. We'll see. Okay. I'll show you another way to do this in just a moment, but right now we're still going by factors. Always start with 1. 1 times 49. So your limit right here, again, just you want to draw it on the side. The smallest number will be number 1, and the biggest factor will be 49. Those are your limits. You want to have factors smaller than 1 or larger than 49. And you have to find everything else in between. All right, 49 is odd, so I can't make groups of 2 out of 49. Nope. 3. Well, if I'm not sure, look, if you're asking, does it work? You're gonna have to do division. Nope, 3 doesn't work either. 3 doesn't work. 4 doesn't work. 5 doesn't work. I can't. Again, if you have a times table chart in front of you, just go down the line. Look at the chart. Nope. But 7 does. I can make 7 groups of 7. 42. Okay, I'm gonna go kind of fast. This book honestly assumes you know your times tables. So honestly, I can't help you if you don't know your times tables. So I might be going a little fast. But all I'm saying is ask yourself the following. What's the biggest factor you can end with? What's the smallest one? So again, keep in mind, between 1 and 42 is where you'll find the factors. Some will have many, some will have few. All right, but you have to know your times tables. Please, you know what? If you have your planner, let me just show you right now. If you have your planner, I don't know if you guys noticed this or not. Look, you can use the times table chart in the back. Okay. 42. We're looking for 42. Now, this may not work for everything, but it gives you an idea. It's an even number. I know 2 will go into it 21 times. If you don't believe me, here's the division. I'm going to do it real fast, but you can verify it for yourself. Right? 42 divided by 2 is 21. Does 3 work? Yeah. 3 times 14. Does 4 work? No. 5? No. 6? 6 times 7. Now, look, I want you to notice something too. Doing it this way, I always start with 1, and I go down, and I go this way. I go in order. If you jump around, let's say you said 1 times 42. Oh, and I know 6 times 7 works, and you stop right there. You'll have missed these 4 factors. Okay? So always start with 1 and end with the biggest number, the number itself. Okay? And just go down the line, count. 1, 2, 3, and ask yourself, can I make groups of this out of that? Can I make groups of this out of that? Okay? Everything in between here and 14 doesn't work. 8 through 13, no. 14 through 20 doesn't work. So if you do this, it gets nicely organized. All right. 21. 1 times 21. That works. 21 is an odd number, so you can't make groups of 2 out of it. 3 works if you know your times tables. You can make 7 groups of 3 out of 21. And yeah, that'll work. So what's the deal here? Now we have to find the common factors. Okay, this might take a little while. 1, 1, 1. 7, 7, 7. Okay. And you really just use your eyes at this point. No 3. There's a 3 here, there's a 3 here, but not there. So it's not common. Again, let me write that definition on the side for what you need to understand about common. Greatest common factor. Common in this respect means shared. Okay? So the 7 is shared, the 3 is not. The 1 is shared here with this one, but it's not here. So it looks like the GCF here is 7. Okay? But what does that mean? What does that mean? GCF is 7. Okay. Let's go back to what we just said. On Friday, she made $49. You know, this means she sold 7 bracelets for $7 each, and that's $49. Saturday, she made $42. That means at $7 each, she sold 6. And for Sunday, she made $21. That means at $7 each, she sold 3. This 7 means that's what the price of the bracelet was, and that was the question actually that was asked. How much did she charge for each bracelet? And you have to see that it works. It leaves nothing left over, right? If I had said each bracelet was $21, it wouldn't have worked out for these. You know, it's the same bracelet. It'll be the same price all 3 days, right? So again, this is a thinking thing. Don't just do the math and say you're done. Because what I'm going to do on the quiz, I'm going to ask you, okay, what's the GCF? And you'll say, oh, it's 7, I got the answer. But then I'm going to ask you, okay then, how many bracelets did she sell on Friday? And you're like, oh no. Or how many bracelets did she sell on Saturday? So this is thinking. Start using that mind. You have one. It's a good one. Use it. All right. We're going to do another example. This is, got it. You know what? I'm just going to use another page. Space. Guys, seriously, you can use the back. I'm not doing it because it doesn't work with these books as well as on a composition, as on a notebook. So If you have this kind of notebook, you know it works better. You can just flip back and forth, no problem. Okay. All right, anyways, this is the got it. I'm going to do letter B. And this is page 8 again. All right. Find the greatest common factor for each set of numbers. All right. Got it? Okay. Now we have bigger numbers. Ugh. When you have bigger numbers like this, it's harder. If you can do the factor thing, you can do the multiple thing, do the 1 times 12, 2 times 6, 3 times 4. It just gets insane. The easiest thing to do at this point is to use a process called prime factorization. So I'm going to write this on the side. When numbers, you know what? That looks like hashtag to you guys. When numbers are huge, use prime factorization. Now see, do you see the mistake I made there? Because I forgot one basic rule. I'm going to tell you this in case I didn't tell you earlier. You have this whole margin. Use it. You know, even the teachers forget sometimes. Use the whole space. Use prime factorization. So let me give you some examples. What it is. You have to ask yourself, I have the product 12. I have this number in front of me. What kind of group can I make out of this number? Okay, I notice it's an even number. I can make groups of 2. Okay, 2. How many groups of 2 can I make out of 12? 6. Okay. Now, 2, I'm going to stop there. 2 is a prime number. And I have a feeling I have to teach you guys this. 2 is a prime number. It only has 2 factors, 1 in itself. Okay, so for example, 2, I can either make 1 group of 2 or 2 groups of 1. It only has 2 factors, 1 in itself. Okay, it's kind of a quick mini lesson there. I'll go into more detail a little later. Now 6, I can definitely make groups of 2 out of that. I can make 3 groups of 2, and 3 is prime as well. Okay, so let me write this in the bottom. 12, the factors of 12 are 2 times 3. Now, if you notice when I multiply these, I will get 12. 2 times 2 is 4, 4 times 3 is 12. 2 times 2, 4 times 3, 12. All right, 66. Now, there's more than one way to start here. I notice it's an even number. I can start with 2, or I can use 11. You know, okay, I'm going to start with 2 just because I like using the smallest numbers possible first. 2 times 33. 33 is negative, but I know my 11s, so I know I can do 11 times 3. And guess what? 11's prime. If you have no idea what I'm talking about prime and composite and all that, I'm going to have to teach you guys. Don't worry. That might have to be a mini lesson a little after this. But okay, 2 times 33 is 66. 11 times 3. Basically, it looks like I'm making, it's called a factor tree. I'm making a tree out of numbers. I'm taking all the prime factors. So 66. The smallest factor there is 2. I'm using a 3.
Freedom is the right of all sentient beings.
It is actually. That was Optimus Prime. It was my phone, by the way. All right, we're looking for the GCF. What factors do they share? What factors do they share? No, they both share a 2. It has to be something that they all share. Now you say, wait, but there's a 2 there. But there's not another one to match it down here. Okay. The GCF then is equal to 2 times 3, and 2 times 3 is 6. Okay. I'll try another one, and then you can do letter D on your own. D. Find the GCF of 18 and 30. Oh, you know, hold on. I did promise I would try this a different way, didn't I? All right. You might want to copy this just to show you, that you can do this differently. 6 times 11, 2 times 3. If you notice, it's the same factors. Sorry, I think my camera froze there. But as you can see, 6 times 11, 2 times 3, the same factors. All right? Okay, 18 and 30. I'm going to go a little faster. 2 times 9, 3 times 3. Okay, 30. Again, just ask yourself the following question. It ends in a 0. I know I can use 10 as a factor, right? I can use 10 to make 30. 10 times 3 is 30. And for 10, I can use 2 times 5, right? And all these numbers are prime. So 18, 2 times 2 times 3, 30 is 2 times 3 times 5. Again, the goal is to find partners. 2, 2, 3, 3. And there it is, it's 6 again. All right. Okay, this one you're going to have to do on your own. D. 32, 48. Find the GCF of these two numbers. Okay. You can use prime factorization, or you can list the factors if you want. Okay guys, I realized the last section was pretty long, finding GCF. It really is a lot easier if you guys know your times tables and know what prime numbers and composite numbers are. But I realize you may not know that, and I will help you with that, okay? Anyways, we're moving on to goal number 2. You have to find the LCM. Okay. So let me just check something real fast before I move on. Yeah. Find the LCM. Okay. Now, if you remember what multiples are, you saw the video. So let me give you an example. This is page 9. Number 3. Okay. All right. It says find the LCM of 2 and 3. All right. What I suggest you do, it really is, if you remember what multiples are, it's in the name itself. You're skip counting, right? You're making multiples, you're multiplying, you're making multiple copies of a number. So in your head you're thinking, okay, 2 times 1, 2 times 2, 2 times 3, times 4, times 5. You're skip counting. 2 times 1 is 2, plus 2 is 4, right? All I'm doing, again, when you're multiplying, it's just repeated addition. 6, 8, 10. Plus 2, plus 2. 3, plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. Okay. Again, it's just skip counting. Repeated addition. Plus 3, right? Alright. So far, you look, there's nothing in common yet. We're looking for the smallest product they have in common. Okay? Otherwise, you can, if you keep going forever, if you look for the greatest common multiple, it'll never end. Okay, now, I'm going to start with another one here. But guys, and I'll be honest with you, after a while, you'll get a hang of this. You'll know instinctively, okay, if I add 2 more here, oh wait, there it is. The LCM is 12. That's pretty much it. If you're finding the LCM, you're just looking for the smallest product that 2 numbers have in common. Okay? Because these are all products. 2 times 1 is the product is 2. 2 times 2, the product is 4. 2 times 3, the product is 6. 2 times 4, the product, and so forth and so on. So let me write this here. You're finding the smallest product in common, right? It's 12. All right, as always, there's another way to do this. If you look at page 9, you can barely see it there. Page 9. Page 9, you have E, F, and G. There you go. All right, for letter E, we have find the LCM of 2 and 6. Okay. Now, I have 2 options here. I can do the whole multiple thing, where I just multiply, skip count. 2 times 1, 2 times 2, oops, excuse me, 4. 2 times 3 is 6. 2 times 4 is 8. I'm just adding 2. There you go. 6 times 1 is 6. Oh, wait, I can stop right there. Okay, that'll work, right? But here's the deal. There's another way to do this. You can also use prime factorization. Again, don't keep switching between pencil and pen. You really should be using pencil. Okay? Anyways, 2 is prime, so it stays where it is. It's just 2. But 6, you have 2 times 3. Alright, so hear me out here. 2, the only factor is 2. There you see. Yeah, you can say 1, but that's a given. Okay? 6, we have 2. I say 2 and I write 3. Something's wrong with my head. 2 times 3. Now, this is where it gets a little different. You line them up. If the 3 doesn't have a partner, leave it blank for on top. And what's going to happen is you do this. You bring it down. So the LCM equals 6. Don't worry, I'll do another example in case you're stuck. Letter F. F. $20. Oh, excuse me. We're looking for least common multiples of 4, 5, and 10. Alright, I'm going to use prime factorization just because. 4, I can use 2 times 2. These are prime. 5 is just prime. The only factor is the number itself and 1. 10, 2 times 5. I can make 5 groups of 2, 2 groups of 5, and those are prime. Again, if you have a problem like, well, I keep saying prime, I don't know what that is. We'll go over it tomorrow, okay? We're going to have to. Alright, but here's the deal. I'm going to start with the smallest number. I have 4. And then 5. And then 10. For number 4, we have 2 times 2. Okay, now watch what I'm going to do here. The 5 doesn't have any 2's. So I'm going to leave it times a blank times a 5. And I'm going to put a blank right there on top of it. Okay? Okay. You ready? With the next one we have 2 times 5. 2. It only has 1 2. I don't have another one. And I have a 5. Okay. Since we're looking for the least common multiple, we're going to end up multiplying everything. Two times 2 times 5. 2 times 2 is 4. 4 times 5 is 20. Okay. I should let you do G on your own, but since it is kind of weird, I'm going to do it for you just so you can get going. When we get to guided practice, you are going to have to do that one on your own. Okay, so here we go. G. 3, 5, 7. Okay, it's going to be weird. 3 is prime by itself. There's no other factor, just one in itself. 5, same thing. 7, same thing. Like, oh, jeez. All right. So how are we going to do this? Again, smallest number. Next one. 3 is just 3. 5, I don't have a 3, so I'm going to do this. Put a little blank under the 3 times 5. And a blank on top of the other one. 7. I don't have a 3. I don't have a 5. But I have a 7. Blank. Blank. Again. I'm multiplying only, let me see here, right? And then, what's 3 times 5? 3 times 5 is 15. 15 times 7. I'm going to do the work here on the side, but you should know how to do this. 7 times 5 is 35. 7 times 1 is 7 plus 3, 10. And that's it for that. LCM 105. Now, what I need you to do now, on the side, summary. What did you learn? And when I say that, what did you understand? Maybe another guiding question to help you out here. How is GCF different or the same as LCM? So what I need you to do, just write 2 or 3 sentences here on the side. We're focusing on positive here. All right. And that's it.